and know everything that's in their tools that they have. And of course, that they know about the other solutions that SOLIDWORKS is offering. And as we do this, as we travel a lot, we rely on tools that exist today to get us from point A to point B, whether it be Google Maps, whether it be Waze, whatever it may be that we're using in the day. So as I was thinking about today's topic of inspection, it very clearly related to this from past to today. So in the past, if you wanted to determine how you were getting from point A to point B, you had to buy maps. Physical maps, and you had to find what the best route was to get from point A to point B. And you probably had to write some notes on a piece of paper beside that to say, I'm going to turn here, and then I'm going to do this turn, I'm going to figure this out. And all of this may have caused some errors along the way because you may have missed one of those steps, or you may have gone right by a street because you missed it, and as you're driving and trying to read your maps and your instructions all at the same time, unless you're lucky to have a navigator with you. So this equates very simply and very quickly to what we are going to show you today. But before I get into that, let's go through a bit of logistics on using GoToWebinar so you're familiar how our tool works if this is the first time you're using it. The interface has a bar on the side that you can minimize if you click on the orange arrow at the top. You can use either your computer audio or phone audio. If you click on phone audio, it will give you the dial-in and access codes to get into that. We've got a handout for you today, so if you click on it, you can download it at any point in time during this this webinar. And then there's a questions or chat area where you can type in questions that you may have for us. So please do so. If there's time at the end, then Michelle will address them, and if there isn't, we have a log of who's asked the questions, and we can definitely circle back to you individually to make sure that those are answered. So now that we've covered this, back to my analogy of maps, right? Manually, when you're doing inspections at your company, chances are, because we know that 85% of our customers are doing inspection documents manually. Whether it creating the bubbles, ballooning your document, your model, obviously in a 2D format, and then of course creating your Excel document, you're individually and manually typing in these informations, and Michelle is going to walk you through what that looks like today. So what we are trying to accomplish with inspection is to be able to reduce the errors and inconsistencies that happen by this being done manually in a company. Obviously, different people doing them could have different ways of doing them. There's time and cost associated to this being done manually. And of course, if we're able to reduce errors and inconsistencies, then in the same span, then we're obviously increasing the quality of the documents that you're producing and maybe creating some consistency in what they look like and how they're done, so that when people actually working with them after get them, that they all look and feel the same, so that it's easy to find your way around. So this is the intent of inspection. The intent is very simple. We're taking something that a lot of our customers do, and we're trying to directly improve on productivity. And if you're there to see the video that we showed at the beginning where it shows a 90% reduction in time, we are not kidding, and we're going to show you how that works and how it can be used. So to do that, actually, sorry, we do have a quote before we start. We have another one coming at the end, but mine is, one of our quality assurance inspectors at our customers indicated to us that it takes them about 2 hours to balloon a drawing and then another 2 hours to create an Excel spreadsheet. So do the math, and we'll show you some of those math equations. 90% reduction in that, what that could save, and how much time your staff or yourself could spend on doing other things in your company. So to show you how all this works, I'm going to invite Michel Cloutier to take the stage. Michel has been with SOLIDWORKS for 14 years, so he has seen not only how and when inspection was introduced, but how we have now linked it very recently to other solutions within the SOLIDWORKS portfolio of data management, and he's going to show you how that all ties in together with how companies can work and make things better. So over to you, Michel. I'll be back at the end.
Well, thank you, Joelle, and again, welcome everyone to our session this morning. So just to put everything back into perspective, so we have this quote from one of our customers saying that it takes about 2 hours to balloon a drawing and then another 2 hours to create the Excel report. Now, if you're doing quality document, you're probably very well aware of the work involved. If you've never been doing that, let me show you a couple of things. Let me walk you through the process of doing those first article inspection report in the traditional manual method. So let's say we have this little drawing and we want to create a first article inspection report for the manufacturing and inspection of this part. What's the steps involved? So the first step is to go around on the drawing and add those balloons on all of the dimensions that need to be inspected. Once you do that, you're going to transpose all those balloons into an Excel spreadsheet. Might actually be a 8.5 by 11 sheet of paper. Then you have to transpose or fill in the nominal values of each of the dimensions. And then you have to go in and calculate the minimum, maximum values for that nominal dimension based on the tolerances indicated on drawing. So I actually have a colleague of mine that did this. Now remember, this is one view. You still have to do the whole drawing, right? So there's more than just that involved. In fact, one of my colleagues, Steve, actually filmed himself doing this task manually, the traditional method. So here we have Steve. So he's using SOLIDWORKS to add the balloons. I've seen customers actually do that with a red pen on the actual drawing sheet manually. But here we're using a digital system to capture everything. Again, a lot of people are doing this very manually on sheets of paper. But just to give you the idea of the task involved. So we've ballooned the drawings, then we go into Excel or another spreadsheet, start putting in all the dimensions. There's a lot of calculation. We use the calculator quite a bit to calculate the lower, upper, lower limits of all of those dimensions. And we fill in all of this done manually. So I think everyone will agree that the traditional process of doing first article inspection report is a very manual process. It's also something that's quite error prone. So it's very easy to put a typo, a mistake when you're transcribing the dimensions or calculating the values. It's time consuming. In fact, Steve took 55 minutes. So Steve took pretty much an hour to do a fairly simple drawing. And we've all heard that time is money. So it's just a costly process to do everything manually. So what I want to show you today is how we can use SOLIDWORKS Inspection to help that process. And we're going to see a few different ways to do that. First of all, do a first article inspection report from a SOLIDWORKS drawing. Then talk about other types of drawings, PDFs, DWGs. We're going to take a look into productivity tools included with SOLIDWORKS Inspection. We're going to deal with CMM. A lot of people doing quality are using CMM to capture the measurements. So how do we repurpose those CMM data? How do we validate that the CMM readout are in fact good or bad compared to our drawing and inspection? And then I'm going to close off with how do we do first article inspection report on 3D data, and I'll get back to that later. So the first thing that we have to understand is that when you purchase SOLIDWORKS Inspection, you actually get it's one software but has two user interface. The first user interface I'm going to show you is the SOLIDWORKS add-in. So within SOLIDWORKS, I'm going to start a brand new article inspection report, again, using a SOLIDWORKS drawing from within SOLIDWORKS. So let's go ahead and jump into SOLIDWORKS and do that. So for your reference, the drawing you see on the background there is the drawing I'm going to use. Again, just to put everything in perspective, this is actually coming off of a component that goes into the camera system of a satellite. So you can expect some very thorough inspection needs to be done. After all, the thing is going into space, right? So let's take a look how we can use SOLIDWORKS Inspection to automate the creation of that inspection report. So I'm going to simply jump into SOLIDWORKS real quick. Like I said, here's my SOLIDWORKS. I'm going to open my drawing. Now my drawing is actually in PDM Professional. Here's my assembly. This is my drawing, so let's go ahead and open that. So as it's opening, obviously we can see the drawing really clearly. Now, as I said, SOLIDWORKS Inspection has two user interface. The first user interface is actually built within SOLIDWORKS. Well, it's an add-in to SOLIDWORKS. So you turn on your SOLIDWORKS Inspection add-in, you get this added toolbar that has a few options, and will create a new inspection report. So the first thing to do when we create an inspection report is to define your project template. I'm just going to use the default template for this one. Click OK. Now in every inspection project, you have some properties. Now the beauty is that since this is done inside of SOLIDWORKS, I can recapture my properties from my SOLIDWORKS metadata. So part number, all of that is already captured inside of SOLIDWORKS. I'm going to add those to my document. What's the document name? Maybe a document number that I have over here. Maybe a vendor, so I have a pull down list that I can edit and build to my liking. Project number. This is really just basic information for my inspection project. One last thing I'm going to add is material, because we see quite often that we want to see the material quite often into the inspection project information. So now that this is captured, the second step is simply to define how I want my inspection characteristics to be built, and also my sampling that we see down the bottom. So we can define a lot size, what's the sampling level, the type of sampling, and the quality level of that sampling. Once I do that, I click next, and then I get to this page where I'm going to select what I want to be used for inspection. So I'm going to define my dimensions, obviously, but you'll see some more information: GD&T, whole callouts, whole table, all that information. When I'm done, I simply click OK, and I'll basically let the software do the job. So I'm not doing anything, hands off the mouse, hands off the keyboard. And at this stage, it's actually SOLIDWORKS Inspection that's looking at all the information on my drawing. And you'll see the balloons start showing up as it's populating. So you see the balloons going up everywhere on each of my dimensions. And very quickly, I've got a ballooned inspection drawing. Now, everything we can do here is we can actually inspect or look at all of these ballooned information. So maybe I want to move those balloons to the right-hand side, so just swap them over here. Now, one reason why I actually took this drawing is to highlight some of the new functionalities we've included in Inspection 2019, namely the whole table support. So you see all my dimensions in my whole table has been captured. So if I scroll down to some of the regular dimensions, maybe I want to go down to, I'll pick one off of any of them. I can right click and say zoom to selection, and that's going to actually bring the view right into that dimension. And we'll take that example, balloon 24, which is 21.28 plus minus 0.50. Now the beauty is all of that information all captured over here. So I got my quantity right here, the dimension, unit, the type of dimension, its length. You'll notice that it actually picked up the tolerances and calculated the upper and lower limit for that dimension automatically. Now, in the video prior, you saw Steve actually do that using his own calculator. With SOLIDWORKS Inspection, no need for that. Everything is done automatically. Now, the other thing too, if I maybe go to another dimension, here's a good one. you can add some information to that. So if I pick the dimension, it's going to come up into view over here. And I can say, for example, what's the operation that the manufacturing operation. Probably more interesting to me would be the inspection method. So for this dimension, maybe I want to use a micrometer. So I can start defining how I want this to be dimensioned or inspected in this drawing. Another example here is how we can organize this information. So you see here I got 2x, 2 times a tap and depth. Now, all of this is captured in my bill of characteristics here, and I can also ungroup them. So for example, I've got 2 holes and I want to have balloons for each of the holes, not one balloon for everything. I can simply ungroup. And so just to show the flexibility of the tool, it's going to create a balloon for each of the hole and each of the dimensions. So the 18 and 19 is actually the tap information, and 2021 is actually the depth information for that particular hole. Now, the other thing I can do as well is come in and let's say that the depth is actually a key characteristic. I can simply right click and put it as a key characteristic. You'll see the little balloon change format to highlight that it is a key characteristic. Again, from there, you can also define the method it's going to be inspected, the classification, the AQL, if you want to override the default settings. And also, again, with regards to grouping, a lot of flexibility. So I can simply shift select 18 through 22, say I want to group, not with a single shared balloon, but group under 18. So I got 18.1, 0.2, 3, 4, and 5. So again, just showing the flexibility of the tool to help you itemize and build your inspection project around this drawing. Now, the output I need from here is going to be my Excel spreadsheet. So from here, I can say what I want to select my my template for my export for my first article inspection report. I'm going to save that into my quality folder inside of SOLIDWORKS PDM. And as it's building my Excel spreadsheet, I'll show you the output in just a second. But remember how long, just think how long this would have taken you to do this manually. Calculate all the upper lower limits, capture all the information into that spreadsheet. Here with SOLIDWORKS Inspection, in pretty much like, I'd say 5, maybe, a little over 5 minutes, I've got everything here. I've got absolutely everything. What's great as well is that I've got my result column here. So if I'm doing the inspection, I can actually start typing in this information right here. And you'll notice that I've got some color validation built into my template. So if I put in a result that's within the value, it shows green. If I put a result that's outside of my upper lower limit, it shows red. So a nice visual cue into that as well. And you'll notice here, this is one of the dimensions where I assigned a inspection method. So again, just great tools to show how we can support all that method and create all that reports in very, very quick way. So let's just close and save that. So as you saw, SOLIDWORKS Inspection is just a great way to automate your report creation. So I did this from within SOLIDWORKS, but what happens if you're working in the quality department and you're not a SOLIDWORKS user and you want to do that on other types of documents, not only SOLIDWORKS documents? That's why when you purchase SOLIDWORKS Inspection, you get both the add-in, but also the standalone. And the standalone allows you to do first article inspection report on other types of 2D data, Think about PDFs or even DWG. So I'll show you the example with a PDF, and actually also show you the example with DWGs. But let's start with PDF. Now, oftentimes people think that with a PDF, there's nothing you can do. Not really true. So within the SOLIDWORKS Inspection, the standalone version, which I'm showing here, I want to create a new project. It's going to be metric, and I'm going to navigate to my PDF file that's inside my vault. So, just a regular PDF of a drawing, and I'm going to open that inside of SOLIDWORKS Inspection. Now, the first thing that I want to define is some basic information. Again, part name, part number, things like that. So what I'll do is I'll simply zoom in to this area where most of that information resides. And typically you would think that you need to type everything back again, but no, here inside of SOLIDWORKS Inspection, we do actually character recognition. So the only thing I need to do is draw a box over what I want the software to read. So for example, the part number, I draw a box over it. The part number, or description, I should say, well, I first took the description, this is the part number. The revision, I can type in if I want to, but it's actually reading these values from the PDF. It's doing optical character recognition. I want to have the material, again, draw a box. So if you're good drawing boxes, you're good using SOLIDWORKS Inspection. That's how easy it is. Now that I've defined those basic information, let's just click OK. And we'll go back at capturing some of the information on this drawing. So let's go back to the upper corner here where we got a few sets of dimensions. And the way that we capture these dimensions is, again, very similar to what you just saw me do with description. I'm going to simply say I want to capture a dimension, draw a box. That's it. As I zoom into this area, let me just pause here a few seconds to show you what happened. I just drew a box. That's all I did. It captured, it understood it's a dimension, length, millimeter, quantity of 1. That's my spec. That's the nominal value. It read the tolerances and calculated the upper and lower limit. So again, people think that, with PDF, you can't do anything. Not true. With PDF, you can read that information and SOLIDWORKS Inspection is gonna make sense of it. If I wanna take a few more dimensions, again, draw a box, angular dimension, plus minus 1 degree. If I move over here, again, draw a box over what I need captured, 150 plus minus 0.5. Same thing here with the 70. Plus minus 0.5. And I took this drawing on purpose because it has different tolerances schemes. So some are plus minus. This one here is plus 1 minus 0.5. So you see that it actually reads the data from the PDF file. And down below here, it's starting to capture everything it needs into that drawing, into my bill of characteristics. We can also capture GD&T information. So for example, I can simply right click and say I want to capture GD&T. I'm going to draw again a box over my GD&T control box. Now this here, I just need to define a little bit further what this is. It's perpendicular. Oh, let me save the project as we're doing it, and I'm going to overwrite the one existing here. So as it's saving, I've defined this is perpendicular. 0.5, I'm going to, again, draw a box and capture the information captured automatically. Type in A for this one. Again, just so easy to work with. You just need to be able to draw boxes. That's how easy SOLIDWORKS Inspection is. So this is a parallelism. I'm going to define my tolerances, B, and there we go. So very quickly, I'm able to capture all of that information. Now I've done this for a single view. Obviously, I would go ahead and do that for all the other dimensions. to save time, let me just open something that's finished that I've done this morning, actually, about an hour ago. So I got this project that's same PDF, same drawing. It's just this one here is just completely done with everything captured. Now, when I got everything captured, again, the idea is to be able to export this information into an Excel spreadsheet. And from here, I'm able to export to the Excel spreadsheet. Oftentimes you want to have a PDF or a balloon drawing, so I can actually capture the balloon drawing into the Excel spreadsheet as well. So here I'm going to save that as knuckle, hit save. It's doing the export. Give it a couple seconds to capture all my dimensional information. Here's my Excel spreadsheet being populated. And there we go. So we can actually get the balloon drawings on the last tab of my Excel report. If I go to the third tab, that's where I'm going to have all the dimensional information captured over here. And again, this has formatting. So if I start typing in information, if I'm within the values, it's going to show green. If I'm inside or outside, it's going to show red. And also for some of the tolerances or dimensions. So here you see I actually captured my notes, so we can also capture notes. So for those, I can't type in a value, but what I could do is say simply pass or fail. And that would prompt again, visual feedback based on those inspection, on those inspected items. So very quickly, let me just close this down and say okay to that. So very quickly, you saw me do that for a PDF file. What about other types of format? Very common, DWG or DXFs. So here's an example, the same process using a DWG. And oh, by the way, when you do this on 2D drawings, DWG, it's even faster. You don't even need to draw boxes anymore. You just need to pick on the dimensions you want tolerance. Because inside of SOLIDWORKS Inspection, we have a smart extract. So by selecting the smart extract, just selecting the dimension captures everything. So I'm selecting those dimensions. I've got diameter, I got GD&T, I got a whole call out. I can window select if I want to capture multiple dimensions at once. So very easily, it's even faster to create this with DWG files. Now, one thing I didn't show that I want to highlight here is that as you're doing that, you can also set your defaults to your default inspection method based on the type of dimension. So if it's a regular dimension, here I've got my settings defined to use a probe or a CMM, depending on whether it's a GD&T or a dimension. Notice as well, if you change the classification of the dimension, the balloon shape changes to have a better visual feedback. So you can clearly see what type of dimensions and what's the classification of those dimensions, if they're critical, etc. So very easily we can do that. We can reorder the characteristics in the table to really your liking. And also, something we see quite a bit is that sometimes you want to distinguish your balloon items based on maybe the method you're going to use. So here, I'm using my sequence starting at 100 because I want to dimension those dimensions on a separate equipment, maybe another different CMM. So this is just a quick way to differentiate where you might want to inspect those dimensions or on a different method. So again, you can change your sequence to better highlight some of those. And again, you always want to capture your Excel spreadsheet, your first article inspection report. You can actually do multiple snapshots and capture those snapshots into your Excel report. very easily. It's really a matter of selecting which snapshots you want to use. When you do the export, you'll see that in the tabs, the different tabs, you have all those snapshots, again, along with all the CMM, or not the CMM, but the uh, information you need inside of your Excel spreadsheet. So really, the SOLIDWORKS Inspection also allows you to leverage all that supplier data, that 2D data coming from your suppliers or maybe your customers. So whether it is a PDF, if you have old scanned drawings, they'll probably be a TIFF file, but we also support DWG and DXF, CATIA V5 drawings, and Creo, PTC Creo drawings. So we can leverage all that information. Now let's move to some of the productivity tools. There's a few productivity tools inside the SOLIDWORKS Inspection I really like to highlight. So let's switch back to SOLIDWORKS Inspection and to show some of those. So first of all, when you have a drawing that's fairly complex, sometimes it's really hard to see where the dimensional information is. It's a little hard to find your way around. So one thing we can do is to simply use a grid system. So very quickly, we can add a grid to that drawing, as you see here. You can define how much rows and columns you want to have in that grid and how you want to number the grid. Now, what's really nice about creating that grid is that inside of your inspection report, we're going to add a column that has the character zone, right? So when you're looking inside of your inspection report in your Excel spreadsheet, it really becomes a real quick way to find where that dimensional information is on complex drawings. So a really nice tool to be able to do that really quick. Another tool I like to highlight inside of SOLIDWORKS Inspection is the ability to quickly toggle between all the extracted information and the information not yet extracted. So for example, if I simply hit hide extracted annotation, quickly I'm hiding all the dimensional information already captured in a bill of characteristics. And as I zoom in, you'll notice that it's very easy to see that I forgot to capture this um, this drill information or this NPT information. So very quickly, I can toggle on and off all the information that's been captured or not. Really, just a quick way to see everything in a glimpse. Probably the best tool, though, the best productivity tool is the ability to compare revisions. So just imagine I've created all of this inspection report on a PDF file, and then my customer or engineering sends me a new PDF file, and I have to start over. The beauty with SOLIDWORKS Inspection is that I can actually overlay both PDFs, one on top of the other, and have a color code that's going to show me what's different in each of those PDFs. So as I zoom into this view here, you'll notice that the chamfer is in black, meaning it's the same, but I got my item 17 that shows in red, meaning it's been deleted in my new revision, in my new drawing. And then I've got those dimensions in green. That's basically telling me those have been added in the new revision. Now, again, you would think that you probably need to start over and redo everything. That's simply not the case. From here, I can simply say, I want to replace this revision. You'll notice that all my captured information is still there. The only thing I need to do is simply update with the dimensions that have been added. So I can simply come in from here and extract this dimension, and pretty much I'm done with my project. I've tackled the task of updating a design or updating this inspection project, and I've done this very quickly, very easily, within a few seconds. So just to show you how quick it is to do that very easily, we can do that inside of SOLIDWORKS Inspection. And it's really the idea with all those productivity tools is to reduce the errors while I'm working and updating those revisions. Now, a lot of customers are using CMM to validate, to do the inspection. How do we repurpose that CMM data inside of SOLIDWORKS Inspection? We can actually read in the CMM data and overlay that CMM data on our SOLIDWORKS Inspection project. So let's go ahead and see how that would look like. I'm going to, again, go back to SOLIDWORKS Inspection. And on this project, I do have some CMM data that I want to bring in. So to do that, I'm simply going to say I want to add file, and I'm going to navigate to my folder where I've got all my inspection data, my CMM data. Now, typically CMM data is only going to be, basically a text file with all the readout information of my CMM. So as I navigate to my folder here, and looks like it's a little slow, there we go. And I look into that text file, so this is one of the readout. If I scroll down, you'll notice this is simply a bunch of measurements. So this is one dimension with nominal and the measured value. This is another one, and so on. So all my dimensions are captured in here. I got actually 3 text files because I did measurements on 3 different samples of my whole lot. So I'm gonna, shift select or control select all the CMM data. I want to say open. Now I got the CMM data inside of SOLIDWORKS inspection, but it's not assigned to all those dimensions. Now luckily for me, I've got a auto assign. I'm gonna assign the dimensions based on the nominal and the tolerance value. I'm gonna hit OK and override whatever tools there is in there. And if I navigate a little bit further into that list, let's expand that a little bit, you'll see all of that data shown over here. Now, if I select any of those columns, you'll even see the overlay color onto my drawing. So you see this is my first sample, and you see all the dimensions are green. If I select the second column, you see that some of those dimensions are actually turning yellow. Take notice of item number 3, 150 plus minus 0.5. If I go to my third sample, you see some of those dimensions are turning yellow, and even this one here is actually turning red, meaning now it's outside of my tolerances. So this is a great way because now we're able to see in time using my samples that some of those dimensions are actually going bad. So as a quality inspection or inspector, that could mean that maybe some of my tools are not calibrated the same. Maybe the manufacturing, some of the tools in manufacturing are getting worn out. So that means that some of those dimensions are going off. So this is great information to capture, and all this captured inside my inspection document. Now, one thing I want to simply remove the first column, so let me just get rid of that. And what I want to do next is to export all that information inside my Excel spreadsheet. So from here, I'm going to send to Excel with my results embedded in my Excel report. I'm going to override the old spreadsheet I did before. So again, it's going in and exporting to my Excel document. And I want to do overwrite. So I'm capturing, I've been able to read in the CMM data, overlay that CMM data onto my drawing, and even output my Excel report. And it looks like I deleted a column here, but we'll go along with it. But all that information is captured inside my Excel spreadsheet, or can be pushed down inside my Excel spreadsheet. So I get all the information in one place at the same time. So really the ability to read in CMM data allows us to streamline the inspection process. So if you have a CMM, normally you would have to actually do that very manually to map the CMM data with the dimensional information on your inspection drawing. With SOLIDWORKS Inspection, you can really map this directly and overlay the information at the same place inside of SOLIDWORKS Inspection. Now, the last thing I want to talk about is how to do first article inspection report from 3D data. And we're seeing more and more of that. A lot of companies are actually annotating a 3D model and not doing drawings anymore. So far, you've seen me do inspection report, but it was always a drawing-based process, either SOLIDWORKS drawing, PDF, DWG. But what happens if you don't have a drawing? You have a 3D model with dimensional information on it. So let's take a quick look of how we can support that. So inside of SOLIDWORKS, so we use actually in this example, SOLIDWORKS MBD, SOLIDWORKS model-based definition, to annotate my 3D model. I don't need a 2D drawing, and I don't actually want to create a 2D drawing, but I want to have my inspection report. So using SOLIDWORKS Inspection, I'm going to create a new inspection report. The user interface is exactly the same. I'm going to define my part number, part name, vendor, basic information of my inspection. I'm going to then select what type of dimensional information I want to capture. Click OK. You see the ballooning happen on the screen. I've got all my characteristic captured, all my dimensional information, plus minus, nominal value, upper lower limit. Everything's calculated automatically. And now I can simply create my Excel report. And there we go. We have our Excel report ready for the quality assurance team. So very easily, we can support that SOLIDWORKS model-based definition or SOLIDWORKS MBD with SOLIDWORKS Inspection. But we can actually go further than that. We can also support 3D data from other CAD systems. So using the SOLIDWORKS standalone, or SOLIDWORKS Inspection standalone, I should say, I'm going to create a new project, very similar to what you've seen me done with the PDF or even the DWG. This time I'm going to select a 3D file, and I'm going to use a PTC Creo part drawing. Now that's a part drawing that's annotated. So as you can see, it's a 3D model with annotations on it. And again, similar to how you've seen me use DWG, I'm going to use the Smart Extract tool. It's one pick, and you select all your dimensions. Now you can also window select the dimensions you want, and you see all the characteristics being captured in the table below. If you want to take everything all at once, just window select over the whole part. There you go. Very quickly, we got all the dimensional information, again, with the value, plus minus, upper lower limit, everything's calculated, even the method of inspection captured automatically based on the type of dimension. Now, if we want to go a little bit further than that, we can also compare revision. Again, you saw me do this on a PDF file. We can do the same on a 3D model. So if we get a new revision, it's a new part file with new annotations on it. You see some color codes starting to show on the screen. And when you look at closer, you see the orange are actually dimensions that I've changed. There's a green dimension that was added, and there's actually one that was deleted. We can actually take a closer look when we look into the left pane. See one deleted, 3 updated, and 1 new. So we can do that manually and select which one we want to update, or simply say, do it automatically for me. All my table bill of characteristics is updated. Now the last thing I need to do again is simply to export that into my Excel spreadsheet. In my first article inspection report Excel spreadsheet. Now, as we're doing that for a 3D model, we can also include screen captures into my Excel spreadsheet, but all my dimensional information is there, ready to go. So with SOLIDWORKS Inspection, we're able to also expand the support for mul-based definition, which is, the support for 3D annotated parts. And we do support other file formats. So obviously we support the SOLIDWORKS parts and assemblies, but we also support CATIA V5 and Creo parts and assemblies. So if we do a quick recap of what we saw today in the last hour or so. So first of all, like I said, SOLIDWORKS Inspection, it's one software, but it's also two user interface. So there's the SOLIDWORKS add-in that runs and lives inside of SOLIDWORKS, mostly used for engineering and for SOLIDWORKS users. But there's also the standalone that allows you to bring in a various number of file types: PDF, DWG, CATIA, PTC, and do a lot more work inside the standalone, bring in CMM data as well. Now, one thing I didn't talk about nor show is also the ability that you can actually start a inspection project within SOLIDWORKS on a SOLIDWORKS drawing, for example, save that into an inspection project, and simply hand that off to your quality inspector, quality department, and say, hey, I've started a draft inspection project. Here's what what's critical for me as an engineer. Pass that down to the quality assurance team, and they can bring that project in and finish it, or bring CMM data, overlay the CMM data. They can do that. So both actually can work together as well. So a quick recap of what we saw. We saw how SOLIDWORKS Inspection can automate the report creation of SOLIDWORKS documents, but also how we can leverage 2D supplier data like PDF, like DWG, things that most of the times people just print and don't really repurpose. We can actually repurpose that, read the information off of a PDF, and help us do the report much faster. We saw how we can reduce errors with some of the productivity tools. Remember just the draw compare tool, right? Where you can compare revisions and update when you get new revisions. That's pretty useful to reduce errors. We can also streamline the whole inspection process if you have CMM information or even just digital calipers and things like that. We can bring those into SOLIDWORKS Inspection and capture all the information at one place. And then the last thing we saw is the expand support of model-based definition or 3D annotated models. So if you're thinking of skipping the 2D drawing, or you want to get rid of 2D drawings, or if you're getting files from your customers that are not 2D drawings, you can actually repurpose them and create your inspection report out of those. So just to wrap up, and I'll let Joelle do the final say the final words soon, but just a quote really that's coming from one of our customers that I think illustrates quite a bit how you can get much faster at doing things with SOLIDWORKS Inspection. So PBC Linear, they use SOLIDWORKS Inspection, and they say that it takes them at most 5 minutes to do an inspection sheet. Without the software, it would take in a technician a day to create the same inspection sheet. So it just proves the point where you can automate a lot of those tedious manual tasks using SOLIDWORKS Inspection. As always, our session is being recorded. It'll be posted a little later today on our channel, where you can find some more information, including MBD. So I talked a little bit about SOLIDWORKS MBD, model-based definition, but we do have a session online that we've recorded a little time ago that's on there that you can watch the recording if you're curious to see that. And with that, I'm gonna let Joelle say the final words.
All right, thank you, Michel. A lot of great information, very clear, very visual. Although very clear, were there any questions that came up that were filed or asked on the chat?
No questions.
No questions. Everybody's perfectly clear on what's going on. Awesome. So obviously, if you think about anything after you've disconnected from this call, which sometimes happens, don't hesitate to contact either of us or your reseller to get more details. Don't hesitate to share this with anyone else within your company who you think would be this would be a value for. So obviously you can either share the link that Michelle had just shown or the one that you have to join this call. We'll also continue to bring you to the recording afterwards of the call. So another number of different options that you have. And hope that we see you on our next events. You'll soon be seeing some invitation emails for some September events, webinars, and some live events if you're possibly in the Toronto area. We're going to focus on simulation. We're going to do some electrical and PCB webinars as well. So lots of things coming. Stay tuned, and we hope to see you on the next event. Have a great day, everyone. Thanks again, Michelle, for all this info, and we'll catch you on the next one.
All right. Thank you, everyone. Have a great weekend.